Okay, let's continue on to the second part of this second unit hydrograph practice problem. Before I begin, I want to make a small correction to something that I'd written wrong on the first one. So it's got to do with the label here for the unit, the 2-hour unit hydrograph in cell N2. What we actually are calculating here is the storm discharge due to the event flow discharge in cubic meters per second per centimeter of effective precipitation. So the units here should be cubic meters per second per centimeter. That's really important. So what we're going to do now is apply this unit hydrograph to the rainfall event described here in the second worksheet. We have a long duration rainfall event that drops a total of, I don't know, let's see what the total precipitation is here. Of all this is a total of, whoops, let's try that one again, sum of 85 millimeters of precipitation falls on this watershed over a period of 20 hours. And we're going to use the 2-hour unit hydrograph to predict what the discharge would look like, what the event discharge or storm flow discharge would look like at the outlet stream by summing the unit hydrograph contributions during each 2-hour increment. So it's sort of exactly the same thing we did last time. So remember, the first thing we're going to need to do is we're going to need to copy over our unit hydrograph that we're going to be applying here in this part of the problem. So I'm just going to grab this and copy and paste. So copy, and now I'm going to just paste it over here. And remember, I need to paste the values, and when I do that I lose all formatting, so let me get all that formatting back. So there we go. And the other thing, remember, I'm going to need is the ratio of effective precipitation to precipitation, because I'm going to assume that that same ratio applies and I can use it for these precipitation amounts that occur during this event. So I'm going to go back and find that ratio of, there it is, effective precipitation to precipitation. And I'll just copy both those things, and I'm going to copy these over into, let's put them right here. So there we go. So that is the scaling factor I need to take my actual precipitation and compute effective precipitation. So let's do that now. Now, one thing to remember now is that this is a unit hydrograph in terms of centimeters, 1 centimeter of effective precipitation. So the effective precipitation I want here is in centimeters. So I'm going to need to remember that this scaling factor just converts millimeters to millimeters. I'm going to need to remember to also divide by 10. So what I'm going to need to do is take the value of precipitation. Let's just do it this way. Let's just convert the value of precipitation in B2, which was in millimeters. Let's convert that first to centimeters, and now we're going to multiply it by that scaling factor in cell M2. There we go. And so now this is the effective precipitation in centimeters, not millimeters. Okay, so let's see if that makes sense. That would be about right. And I'm going to copy this all the way across. So now I have my effective precipitation in centimeters for every time increment. I have my 2-hour unit hydrograph, and I'm going to do the same thing I did for the first practice problem, which just simply copy my unit hydrograph scaled by the actual effective precipitation that fell during that time increment. Now the first time increment will start at time 0, so what I'm going to do is take the value here, that's P3, so I'm going to take the value, this is the unit hydrograph, and scaled by the value in B3. There it is, right? And then I'm going to simply copy that all the way down. I'll copy it all the way down. It's way longer than I need here. There we go. And I'm going to do the same thing for the second increment. Now remember, the second increment, it's a 2-hour unit hydrograph, so the second increment is going to start 2 hours after the first. So I'm going to take P3 and I'm going to scale that by C3 and copy that all the way down, etc. So let me go do that. So this is what it looks like. Notice that each unit hydrograph is offset by 2 hours because it's a 2-hour unit hydrograph based on 2 hours of effective precipitation for each one. And now all I need to do, these are the calculate the total in cubic meters per second, right? And that's just going to be the sum for each row here of the contributions from each time increment. The first one obviously doesn't have anything except the first increment. I'm just going to copy this down. Yay. Okay, there we go. So now we've essentially determined our storm hydrograph. Here it is. It's time in column A versus discharge, the total discharge from all 8 increments, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 increments of precipitation shown in column L. And so I'm now just simply going to plot the time here versus the, let's just look where it sort of goes to 0, it goes to about 80, so I'll just start there. I'm going to stop there. I'm going to go plot the time versus the discharge, and that will be my storm hydrograph based on the unit hydrograph theory. And notice it looks a little different here, right? It's got a couple peaks, which is because the precipitation event has a couple peaks. You see there's one here and then there's another one there. So my storm hydrograph looks a little different here than it did the first time. We have everything we need to know. Let me just slide that over here so that's out of the way here. We could put all the labels on it and stuff like that for now. But meanwhile, we're told to calculate the peak discharge and the time lag from the beginning of the precipitation event, the lag to peak. So we can see here, we'll just go down to the, actually let me slide this over a little bit more. We can see that I'll write it over here. So the Q peak in cubic meters per second will be, let's see, it's going to be right here at 31.6 cubic meters per second. Right? Oops, that's not what we wanted to do. We need to put that somewhere else, don't we? Okay, let's put that over here. There it is. Okay, there's the Q peak, 31.6. Let's just put that in red. So that's one of the things we needed to find. And we also needed to find the time lag between that 31. Now, one thing to point there is the second peak. When we find the second peak is occurring here at 28.02. But the major peak occurs at 31.6 right there. And the time lag would be 12 hours. There it is. So the Q peak in time is 12 hours after the onset of precipitation. So there you go. There is the solution to the second unit hydrograph problem. Pretty similar to the first, just a few differences related to the metric system and the 2-hour nature of the unit hydrograph.